where is cos a half? You can use your unit circle, pull the unit circle out. I'm going to draw a rough sketch on the left-hand side. I always work with first quadrant and then reflect. Where is cos a half? So I know at 60 degrees, cosine is a half because it's 1/2 root 3 over 2. And tangent is root 3 up here. So cosine, sine. Can reflect, reflect, reflect. I'll fill in here 30, 30, 60, 60, 30, 30, 60. Okay, so cos is positive a half right here. All students take calc. So we know cos is positive in the first quadrant and in the fourth quadrant. So first quadrant, it's at 60 degrees. And then in the fourth quadrant, it's 270 plus that sliver. So we'd say 270, right, plus 30. 270 plus 30, so 300. Now next thing, it says where is cos -1? So positive, -1, and 0, right, are on the axes. So we know over here we have 1, 0, we have 0, 1, we have -1, 0, and we have 0, -1. So as we spin around the unit circle, where is the left-hand side -1? Right here at 180 degrees. Right? So we could fill that in as pi, right? 180 is pi. We could write 60 degrees as pi over 3, and we could write 300 as 5 pi over 3. Remember, to convert, you can do 60 degrees over 1 times pi over 180, and 60 divided by 180 gets you pi over 3. So if the answers were in radians, I would convert to radians if you don't have it in radians, and convert to degrees if you see it in degrees. Okay, let's do one more. Now let's practice using the quadratic formula. Now notice when it said cos x equals a half, cos x equals -1, those were values also that were on our unit circle, right? When you see ratios on your unit circle, integers on the unit circle, you know that you don't have to put in your calculator. If, let's say, said cos x equals a third, you'd have to go to your calculator and plug it in. So if it said cos x equals a third, since a third isn't on your unit circle, that's when you'd have to go to your calculator and then figure it out using calculator. And we're going to have to do that in a sec with the quadratic formula, so we'll practice in a minute. Okay, last problem. If we look at one that has us use the quadratic formula, we'd have to do the following. So we'll say number 5, use quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. So if we had a problem that said 2 tan squared x equals 3 tan x plus 7. Well, first step is I always like to have a positive a value, okay? If this, for example, was a -2, I would move the 2 tan to the other side. That's really more for factoring, okay? But I'm going to move everything over here by tan. So I have 2 tan squared x minus 3 tan x minus 7 equals 0. Your first thought should be, can I factor? Is there a combo that multiplies to AC, so 2 times -7 or -14, that adds to B? B is -3, right? Let's see. 1 and 14, we could play around with the negatives, right? Negative 1, 1 and negative 14. No. That is 13, that is negative 13. We could try 2, 2 and 7. So negative 2 and positive 7, 2 and negative 7. Those multiply to negative 14, but they don't add to negative 3. If I go down, there's no combos that work. So if you can't factor, you have to use your quadratic formula. So in my quadratic formula, if I had 2x squared minus 3x minus 7 equals 0, we know a is 2, we know b is negative 3, and we know c is negative 7. So if you come up here in the b slot, we're going to write negative 3. So we'd have x equals negative, use parentheses when you insert, negative 3. You should have this double negative here. Plus or minus square root b squared, so negative 3 squared, negative 3 is in parentheses, minus 4 times a times c all over 2a. Notice I use parentheses for inserting. People will have trouble if they don't use parentheses here. They'll write negative 3 and it's going to throw off your answer. So I'd have x equals 3 plus or minus the square root of 65 all over 4. Also, just make sure that you get 65 under your radical. If you don't, it's because you didn't use order of operations. So just be careful with that. So now we're going to say x equals, we can throw that tan back in there, tan x equals 3 plus root 65 over 4. Tan x equals 3 minus root 65 over 4. Now I know these values aren't on the unit circle, right? So 3 plus root 65 over 4. Gonna round, let's see. So root 65 plus 3 divided by 4. So we'll get about 2.77. We'll just say 77. And down here, we'll get 3 minus root 65 divided by 4. So we'll get negative 1.27. So now what we're going to do is, if we're asking ourselves tan x equals 2.77, we're asking ourselves, where is tan 2.77 on our unit circle? So what we have to do in our calculator is we have to hit inverse tan of 2.77. And when we hit inverse tan of 2.77, we get, I'm just going to say right now, about 70 degrees. Make sure your mode is in degrees. Then over here, if I say tan x equals negative 1.27, you're saying, where is tan negative 1.27? Well, negative 1.27 is on our unit circle, right? So we're going to say inverse tan of negative 1.27. Inverse tan of negative 1.27. And I'm just going to round it to whole. So I have negative 52 degrees about. Okay? Now let's come over here and figure everything else out. So for the first one, if we figured out that tan inverse of 2.77 was 70 degrees, we know that if we're looking for that positive value, positive tan value, we're going to have positive tan in the first quadrant, all are positive there, and we're going to have positive tan in the third quadrant, right? Because the original problem said tan x equals 2.77. So you're looking for where tan is a positive value, first and fourth quadrant. And then when we used our calculator, we found that inverse tan of 2.77 was at 70 degrees. So one of our answers is 70 degrees. And then the other one is going to be 180 plus 30, right? So if this is 70, this sliver's 20, this sliver's 20, this sliver's 70, this sliver's 20. So 180 plus 20. So we'd say 200 degrees. Oh, sorry, I screwed something up. Let's see, 70, so 70 degrees, check. But if I reflect to get the other positive tan value, 70, 20, 20, 70, this should be 70. Sorry. So 180 plus 70. So 180 plus 70, so we'll have 250 degrees. So again, because it said, where will we have a tan value of positive 2.77? This didn't say 1. If it said 1, we'd have it here at 45, and we'd have it down here, right? However, this value isn't 1 root 3 or root 3 over 3. So we used our calculator. We found inverse tan of 2.77 was 70 degrees. So we know at this spot, 70 degrees, we have our first value. Then, if we reflect, we know our other tan value will be down here in third quadrant. So based on my reflection, I did 70, 20, 20, 70, 70. And so as I start to spin to that terminal side, I have 180 plus 70, right? And that's how I also get 250. And then lastly, if it says tan x equals negative 1.27, right? Tan x equals negative 1.27. You can't look at your unit circle and figure that out, right? Because negative 1.27 isn't on the unit circle. So when we put it in our calculator, we get negative 52 degrees. So what it's saying is at this spot, negative 52 degrees, we'll have that ratio. However, in the beginning, it says we want our answers between 0 and 360. So we need to figure out what this same spot is that's between 0 and 360. So what we can do is we can spin around and say 270 plus this little sliver, right? And we know this little sliver is going to be 90 minus 52. So 38. And then we can say 270 plus 38, so we'll get 308. So for tan x equal to negative 1.27, we found that one spot is at 270 plus 38, which is 308. And then we also need to see what other quadrant. So we have all students take calc. So where else will we have a negative tan value? We have it in the fourth quadrant, right? And we have in the second quadrant. So if I use this little sliver concept, let's see what I'd have. So I know this little sliver is 38, this is 52, this is 52 then, this is 38, this is 38, this is 52, 52, 38. So I know that to get to this spot, it's going to be 90 plus 38. So we're going to do 90 plus 38, so we'll have 128. So the other spot is 90 plus 38, which is going to get us 128 degrees. So we're going to have four answers: 70 degrees and 250, 308, and 128.